Today we're going to be working with binomial radical expressions. So first let's look at like radicals. So we can add or subtract like radicals if the index and the radicands are the same. So for instance, if we had a square root, we'd have to have a square root. So the index meaning what root are we working with. If we have a cube root, that means we have to have another cube root. The radicand has to be the same, meaning the number underneath our radical. So if we have the square root of 2, the number has to be square root of 2. If we had the cube root of 4, we have to have the cube root of 4. So the index, meaning what radical we're working with, and the radicand, the number underneath our root, needs to be the same. So let's look at some examples. Add or subtract if possible. So here our index is the same because we have a square root and a square root. Our radicands are the same, which is a 5 and a 5. So we can subtract. So 2 minus 5 is a negative 3. Square roots of 5. So here we have the same index, cube root and a cube root. Our radicands are the same, they're both x's. So we have 1 cube root of x plus 7 cube roots of x means we have 8 cube roots of x. So then our last example, we have the same index, they're both square roots, but our radicands are not the same, one's 7 and one's a 5, so this is not possible. So let's take a look at how we can simplify when right now our radicands are different by simplifying first. So let's factor out 20. So we have 2 and 10, 2 and 5. So this turns into 5 square roots of 2. And I'm adding. My 45 is a 5 and a 9. 9 turns into 3 and 3. So I have 3 square roots of 5. My indexes are the same. My radicands, this should be a 5. 2 square roots of 5. Wrote that backwards. Pull out a 2 and I have a 5 left over. So my indexes are the same and my radicands are the same. So 2 plus 3, so we have 5 square roots of 5. Let's take a look at the next one. We have 18 is 2 and 9, 3 and 3. So we have our original 6 times our 3 square roots of 2 plus our original 4, and then our 8 turns into 2 and 4, 2 and 2. So we have times by 2 square roots of 2 minus 3. 72 is 2 and 36. 36 is 2 and 18, 2 and 9, 3 and 3. So we have a group of 2s, a group of 3s, and we have a square root of 2 left over. So we simplify this. 6 times 3 is 18 square roots of 2 plus 8 square roots of 2. Negative 3 times 2 is a negative 6 times 3 is a negative 18 square roots of 2. Positive 18 square roots of 2 and a negative 18 square roots of 2 becomes 0. So we have 8 square roots of 2. So let's look at this last example. 50 is a 5 times 10. 2 times 5. So that means we have 5 square roots of 2 plus 3. If we factor the 32, we have 4 and 8, 2 and 2, 2 and 4, 2 and 2. So we can take out a 2 and a 2. We have a square root of 2 left over. Minus 5, 18, 2 and 9, 3 and 3. So times by 3 with a square root of 2. So 5 square roots of 2. 3 times 2 is 6. Times 2 is 12 square roots of 2. Negative 5 times 3 is a negative 15 square roots of 2. So 5 square roots of 2 plus 12 square roots of 2 is 17 square roots of 2. Minus 15 square roots of 2. So 17 minus 15 is 2 square roots of 2.